tomorrow. All right, and we'll have like a review activity, kind of get moving around the room a little bit. That'll be Wednesday. Kind of review 10-4, 10-5, 10-7. We're skipping 10-6. And then we'll have a review, like an actual quiz review worksheet on Thursday. And then a quiz Friday. Yes, a physical quiz review worksheet on Thursday.
Thank you.
You're welcome. All right, so we have 10-5 today. Angle relationships in circles. All right, so we've got just a quick refresher. The angle types you should know by now. We called this a central angle. We called this an inscribed angle. Okay? Central angle, the angle equals its arc. Inscribed angle, the angle is half the arc, or the arc would be double the angle, right? Now today, we're going to learn a couple new types. Well, if we had one at the center, we had one on, I guess we could have an angle that's inside but not at the center and not on it, right? And we could have an angle that's outside the circle altogether. When I say outside or inside, I'm talking about the vertex, right? We're talking about the vertex of the angle. Where is it? Is it at the center? Inscribed? Inside or outside? Okay? So central, inscribed, inside or outside. Those are the types of angles we're going to be dealing with in this chapter. All right, so tangent, chord, angle. Now this one, it looks kind of weird, but it's the same rule we learned on Friday. Where is the vertex? At the center of the circle? No. On the circle? Yes. So it's the same rule we learned last week. Last week, the angle is half the arc. So the only thing you have to kind of draw your eyes to on this one is to be careful of is that the vertex is on the circle. And then the next question is, what's the arc? Because the angle is going to be half the arc again. Well, the arc, watch up here for just a second. Do you agree the arc goes from here to there? Right? It's kind of weird because last week we talked about inscribed where we had two chords going across the circle. This one's a tangent and a chord. If you have a tangent and a chord, the intercepted arc is going to go from vertex to the other endpoint of the chord. So we have half the arc. So the measure of angle ABC would be 60 degrees. Pretty easy. That's just a special case. Instead of two chords, we have a tangent and a chord. But again, I would still call that an inscribed angle. Okay. Fits the rules from Friday. All right, we'll do a couple quick examples of this and then move on to the main stuff for today. You good? All right. Line M is tangent to the circle. Find the indicated measure. All right, quickly. What's the measure of angle 1? Got calculators out. 65 degrees. Very good. It's half of 130. Over here. Now, be careful. They could ask us the arc, and they did. If we're looking for arc KJL, KJL, you have to kind of identify that 125 degrees is going with that angle there. Angle, the measure of angle KLN is 125. So the arc is going to be double. Good, 250. 250 degrees. Arc is double the inscribed angle. All right, now these are where we have intersecting lines. So they describe them as non-parallel. Obviously, they have to intersect if they're non-parallel. All right, there are 3 places where lines can intersect a circle. First case, on the circle. Vertex is on the circle. Second case, vertex is inside the circle, not necessarily at the center. And the third case is outside the circle. Each of these requires a different rule.
Do you want us to draw these? Or no?
I'm trying to think. The 2 intersecting chords. You know what? We don't have the rule right now for these. So if you want to have a picture of the 3 scenarios, that's fine. I would say this is optional. Okay. So if you want to write this or draw this, you can. Not required. The 2 intersecting chords is our next slide. Anybody writing this down? I can give you another minute. All right. Tell you what, I'll do this. I'll pause it over there. And at least start talking about the next one. All right, 2 intersecting chords, angle. So notice it is the vertex. That's the main thing you're looking for. It is the vertex of the angle at the center of the circle. No, it's not at the center, but it is inside, right? That vertex is inside the circle. Yes, Tally?
Where are we writing this intersection lines and circles?
That is optional. So if you want to have that down somewhere in your guided notes, you can put it anywhere you want. This is the next actual fill-in, I think. Now, as you do a problem like this, it's going to be a good habit to probably draw the circle. And the next thing, especially important, is to label the angle you're trying to find. There's a lot of angles in this picture. Okay? If they're asking us for BED, that's this angle right here. BED. And what the notes say is we have 2 sets of vertical angles. Do you see the green set that I just labeled? Obviously, if we're trying to find BED, we can find either one of those, and it's going to be congruent to the other, right? We can find either one of those green angles because BED and CEA are congruent by the vertical angles there. But do you see the other pair of vertical angles? Right? And don't they form linear pairs with each other? So it's not so bad. If you're asked to find CEB, I'll show you how to do that as well. We can still use a formula and then subtract the angle we find from 180 to get the other one. So here's how the rule works. By the way, everybody who was on that slide, are we good to move on from that diagram? Okay, I want to display it on both. Here's how this rule works. I will call this an inside angle. The vertex is inside the circle. And the formula is half the sum of the intercepted arcs. Sum means to add. Okay, so let's get rid of the blue angles because the one we're trying to find is BED. That's what they told us to find. BED. That's the green one. So when we're talking about intercepted arcs, it's always, for an inside angle, it's always the arcs that the angles are facing. That's what an intercepted arc is. So watch up here for a minute. Everybody see angle BED right here. What arc is it facing? 70. That's one of the intercepted arcs, is 70. Okay. And we're told to add. Okay, what's the other intercepted arc? Well, its vertical pair is facing 170. But we're told the formula is half of that sum. So you're always going to add them together and take half. So you can either add them together and divide by 2, or add them together and multiply by a half. And you're going to find the angle that's facing those arcs. Not the other ones, the angles that are facing those arcs. All right, let's do the parentheses. What's 70 plus 170? 240. What's half of 240? 120 degrees. So this angle is a 120 degree angle. Its vertical pair is 120 degrees. The linear pair would be 60. So there's going to be a case where you will be asked to find one of these angles. You're like, wait a minute. I don't have the arcs. I don't have the 2 intercepted arcs that those are facing. How am I supposed to find them? Well, find the pair that you can and then subtract it from 180 to get the others. That's it. All right? All right. Angles formed outside a circle. New formula. All right? And this is for 2 tangents. All right? 2 tangents, 2 secants, and by a secant and a tangent. Half the difference. Difference means to subtract. Half the difference of the intercepted arcs. Well, can that angle be negative out there? No, you can't have that negative angle out there. So when you go to subtract, obviously you're going to do the bigger one minus the smaller one. Okay, so it's a positive angle. Half the difference. So the way I like to think of it is half of the outer arc minus the inner arc. Half the outer arc minus the inner arc. And when I say outer and inner, that's based on the angle you're trying to find. So if we're looking at this angle B, the outer arc would be the one farthest away from it. Outer. What's the angle that's the outer arc? If we have these 2 tangents touching the circle, the outer arc would be 260. Subtract. I'll do the inner arc in green. What's the inner arc? 100. And we're told to take half the difference. Half the difference. Well, 260 minus 100 is 160. Half of 160 is 60. Careful. 80, right? It's all right. It's a Monday and nobody else is participating, so it's all good. The measure. Oh, come on. See, my smartboard doesn't want to work either. The measure. 4 times the charm. The measure of angle ABC. We said 80, right? Now, I think I don't know about you guys. I bet it wouldn't take too much of an argument to tell you if you have 2 tangents, those 2 arcs are always going to add up to what? If you have 2 tangents, the outer arc and the inner arc should always add up to 360, right? Now, secants would be different. Secants are 2 segments or lines that touch the circle twice. So 2. Now, when I say they're going to be different, all I mean is that they're not going to add up to 360. Okay, but we have the same formula. All right, here we go. See the angle. The first thing you should ask now, we're kind of isolated in this problem because we're working on outside angles right now. But do you all agree this vertex of this angle is outside the circle? So it's going to be half the difference of the 2 arcs. Well, from C, what's the outer arc? AE, which is 80. What's the inner arc? 20. So the measure of angle ACE is half of 80 minus 20. minus 20. Oh, now nobody wants to try. Half of 60. Third. 30 degrees. All right. And the last situation is when you have, well, let me back up. Did you guys all recognize AC and CE were both secants to the circle? Are we good with that? Secants? Yes. And the last scenario is if you have a secant and a tangent. Secant and a tangent, all right? AB would be called a tangent. DB would be called a secant. Still, same rule. Why the same rule? Because B is outside the circle. Well, what's the outer arc now? 100. And the inner arc is 30. Half 100 minus 30. What do you get? What'd you say?
45.
Not quite. Close.
35.
Yep, 35 degrees. 100 minus 30 would be 70. Half of 70, 35 degrees. But notice, all three of those situations, they were the vertex was outside the circle. Half of the difference is the formula. All right, let's do an example, and then I'll let you guys try one. All right, we got angle EFH. EFH. What's the vertex of that angle? What's the letter? A vertex is a point. F. Very good. The first question you should ask yourself, is that vertex at the center of the circle? No. Is it on the circle?
Yes.
Yes. And then the other questions, if you didn't say yes yet, would be, is it inside or is it outside? Central, inscribed, inside, outside. Those are our four types of angles right now. It's an inscribed angle. So what's the angle? Half the arc. Well, half of 130 is what? 65 degrees. All right, next one, arc GF. Arc GF. What's the vertex that we should use to find that arc? What vertex? I hear F, I hear G, I hear H. Okay, let me trace it again. Ready? Arc GF. So the first question you should ask yourself, what two chords, what two secants, what two tangents, what two whatevers intercept that arc? What two segments or lines or rays or whatever intercept arc GF? H?
FG.
FG? And I don't know what to call the other one. What would you like? If we had another point on it, we could name it better, but let's call it K. And line KG. Do you agree with that, Paige?
Mm-hmm.
Do you guys all agree? What intercepts this arc? Well, segment GF and line KG. Yes? Okay, well, if those are the two parts that make up the arc, it's this angle that we need to know, because that arc would be blank compared to that angle. Well, that vertex is on the circle. So what's the relationship between the arc and the angle? The arc is double that angle. Do you agree? So how do we find that angle? How do we find this blue angle, Jared?
180 minus 122.
Very good, because they're a linear pair, aren't they? Yes? All right. What is 180 minus 122? 58. Good. If this angle is 58 degrees, then the arc we're trying to find is double 58. What's double 58?
116.
116 degrees. Make sure you guys are practicing labeling degrees. 116 degrees. You see how to do that one? They're like little puzzles. You got to kind of work your way around with what you know. I think it's time for you guys to try.
Oh, that's not
I think it might be a good one to draw on your own.
Listen to how spoiled you guys have become. Like beginning of the year. We've never had guided notes before. Fast forward to third marking period. We have to draw a circle on our own. I didn't say a single word.
Thank you so
You know
much.
what we're doing? Okay. I'm just gonna draw with a little. Yes. It's a good meeting. It's very good.
You decide on.
You're just objectively wrong.
Practice or try.
You should be. It doesn't matter. It's a calculator. It calculates.
All right.
I'm not even done drawing yet.
I didn't play this year, but yeah.
I did a
83 grants too. This is seventh grade. Scribbled all over my screen. So
I did.
Huh?
Huh?
Oh,
First grade,
do the
yes.
art project.
It's just like 10 years ago.
I had this calculator. I haven't lost one. This is your
Did
third.
you ask if I golf?
This is my
You
third.
feel like a golfer?
Yeah. And then he goes back.
Huh? I do?
I don't hear him. Because it was so long.
What'd you say?
I didn't know that. Yeah. No, I know. I'm on your
All right. STU. Oh, look. Vertex T is on the circle. The angle is half the arc. What's half of 166? 83 degrees. So bring it 83 degrees. And arc SR. Well, the arc, look at the angle. It's on the circle again. The arc is double the angle. What's double 71? 142 degrees. All right, in case you might have been sleeping somewhere during the lesson, quick review. Central angle, the angle and its arc are equal. Central, angle and the arc are equal. We haven't seen any of those today. Second type, inscribed, the angle's half the arc. The good news is after central, the other three have to do with a 1/2 in it somewhere. Okay? Inscribed, the angle's half the arc. Inside, it's half of the arcs added together, and outside, it's half of the arcs subtracted. Good?
Inside is added, outside is subtracted.
Because when you go outside, it's like you've been taken away from everyone else, right? I mean, like, you're missed. Next. Ooh, AEB. All right, first, is this in your guided notes? Oh, how generous. Okay, here we go. Ready?
Quiet. Hey guys, you're gonna complain. When we get to the end, you're going, all right. The first thing you should do, mark the angle AEB that you're trying to find. AEB. Oh look, its vertex is in not in the center. It's inside. Inside. It's an inside angle. So as soon as I see inside, quiet please. Hey guys, we should not be talking right now. Guys, thank you. Inside, as soon as you see inside, you should, I would even write out the formula. Half of two things added together. I don't know what those two things are yet, but just write it out. It's half of two things added together. Okay, so I marked my angle with an arc mark. And then the next thing I do is I look to see what the angle faces, which arcs the angles face. Ready? 139. And because of its vertical pair, the other one faces 113. Everybody see where I'm getting those from? Awesome. Add them together. Take half of it. 139 plus 113. What's that? 252? Half of 252 is like 160. What's it? 126. 126. Thank you. The last thing is once you do that calculation is to make sure that's the angle they asked you for. Well, we marked those. If for some reason they asked us to find one of those, we'd have to do some more math. But that was the angle we were asked to find. We were in good shape. 126 degrees. Next. ABD. Not on there? Let's skip it. All right. All right. Try this one, and I will tell you to be careful. Ten cuidado. That was Spanish. Be careful.
Just because I take Spanish doesn't mean I know everything.
This one?
No, it's fine.
I did a plus, but you probably read it. I don't know. Is it the one that you add on? No. Is it the difference?
R N M.
Well, then it would be minus. Because that is the 80.
That vertex angle is outside, inside, central, inside. Inside. Half arcs added. Now the only angles, in case you've tried it, I don't want you to get stuck and get frustrated and cry in your head. The only angles we can actually find are which ones? The ones facing the arcs. But did you notice they asked us for R and M? This little angle does not face those arcs. So here's what we're going to do. We're going to find the angles that do face the arcs because that's the only angle we can find. Are you ready? Half of 91 plus 225. Help me out. What's that? 116? But be careful. That's these angles, correct? That's not the angle we were asked to find. We're asked to find the linear pair to that, aren't we? Aren't we asked to find R and M? 180 minus 116. Oh, thank you. Thank you.
I just.
158? 180 minus 158? 22 degrees? So that is that blue angle we were trying to find, 22 degrees. Does it make sense?
I got it.
Well done.
All right. Next one. We're asked to find x. You guys, quiet, please. Which kind of angle is this? Is that vertex at the center of the circle? No. Is it on? Is it inside? Is it outside? Outside. Outside. Outside, everybody. Outside. These are two tangents, or two secants. Two secants. All right. As soon as I see that that vertex is outside, I think half of two arcs subtracted, don't you? Don't you? And you should always subtract outer arc minus inner arc to keep it positive. So we're going to do outer arc, 87. Inner arc, still 7. I'm not going to trust you guys again with the calculator, so here we go. 87 minus 7? 80. Half of 80? 40 degrees. Just like today. Beautiful 40-degree day out. All right, let's see how much time we got left. You guys can do that. I don't trust you with this one. All right. We're skipping this one. That's a pretty straightforward one. Yeah. Awesome. I didn't want to hear you guys complain about drawing anything anymore. All right. This one. Careful. Careful. This vertex is outside, so I'm thinking half outer arc minus inner arc. However, I don't have either one of those. Or do I? All right. This, quiet please, this 135-degree angle is a central angle. The arc that it goes to is congruent. So that is a 135-degree arc. You all see it. Now, because these are two tangents, isn't this major arc? Everything else in the circle except for 135. 360 minus 135. 225. So what's going to go in our calculation? Ready? Here's our angle. It's an outside angle. It's half of the, what's the outer arc? 225 minus, what's the inner arc? 225 minus 135. I'm getting 90. Half of 90. That's a 45-degree angle. You don't want one. All right, letter B is kind of tricky. I'm going to save that one for later. If you want to try that on your own sometime, it's pretty entertaining.
Yep.
All right, this is the one I want to make sure we have time for to finish class. All right, the rest of them should be review that you guys can kind of do on your own. Tell you what, we're going to skip around. Change my mind quickly. Do you have this one in your paper?
Yeah.
Okay, I do want to show you this. Okay, this one's also a little tricky. This angle is outside the circle. So isn't the measure of angle BDA half of the outer arc minus the inner arc? Yes? What's the outer arc? AB or BA? 88 degrees. What's the inner arc? We don't know. Let's call it X. Do you agree it's going to be 88 minus X inside the parentheses? So where's that 35 going to go? Well, this one's a little tricky because you're not finding one of the arcs. Or one of the, I'm sorry, you're not finding the outside angle. You're actually finding one of the arcs. Okay? Let me say it again. You're not finding the outside angle. You're finding one of the arcs.
So the angle they gave us goes here, right? That's already solved for. Now, be careful. These need to go in parentheses. You understand how to use the formula, all right? So we're going to distribute this 1/2. Or would you rather, I would probably multiply both sides by 2 to get rid of it. Would you agree with that?
Yeah.
If you guys are comfortable with that or not. If I'm trying to get x by itself, I want to get anything over there to this side. So if I multiply both sides by 2, I'm to that point. Okay. Add x, subtract 70. I'm getting x equals 18. Do you agree? So that is a 18-degree arc. 18 degrees. I would need to see some sort of work for this. I know some of you could probably guess and check at that answer. You probably take half of some, 88 minus something, and kind of guess and check at it to get 35. Okay, I'd like to see some work there. All right. We'll get back to that Earth problem. Let's see. We're not going to actually do this one. I want to walk you through it, though. How would you find, if you're going to do this angle, wouldn't you need to know this arc? How would you find it quickly? 360 minus it. Good. That's good. All right. And then for this one, you'd have to recognize that if you called this arc like K and this arc P, I don't know. You have to do half of those two subtracted to get 36. Okay. That one's a little tricky too. So I at least want to walk you through this kind of problem. You're asked to find arc measure of arc BD. They tell you the radius of the Earth. It's pretty close to 4,000 miles. They tell us that the distance from the center of the Earth out to this, I think it's a satellite. Is it a satellite? Probably one of Elon Musk's satellites. Earthlink. Giving internet to the Ukrainians. All right. Check into that. It's actually kind of cool. All right. AC is 4,300 miles. We're asked to find arc BD. All right. I'm going to give you a little hint. If we're going to find that arc, and this is, do you agree these are central angles? If I can find that central angle, one of these, then this arc right from here to here is equal to that central angle, right? And because these are going to be congruent triangles, reflexive property, radius, right? Because those, so hypotenuse, leg, congruent triangles. How would I find one of these angles if I know this side is 4,000 and this side is 4,300? Any ideas? Well, Pythagorean theorem finds sides, but we want to find this angle. SOHCAHTOA, right? And we want to use the 4,000 side and the 4,300 side. Those are the, what two sides?
The hypotenuse, the
Adjacent and hypotenuse, right? And we're going to have to inverse to uncover that angle. So the cosine, let's call this angle P. Cosine of P is the adjacent side, which is 4,000, over the hypotenuse, which is 4,300. And to uncover P, you're going to have to do the cosine inverse of both sides. Now, that will give you one of these angles. Because they're congruent, you'll double it, and then the arc's going to be congruent to that. See how that's a few steps to get there. Do you understand the process? In case you see one of those on the homework. Oh, get excited. Wonderful opportunity for learning there. Speaking of homework.
I said that. I'm scared. Fine, you're not used to taking these classes.